Greetings to all the students. Once again, there is a continuation from the chapter of human digestive system. So today's subtopic under human digestive system, digestion, diet is another subtopic, food tests. So today we will be seeing food test and calorimeter experiment. So the first food test is a very simple test for starch. Even you students can do it at home also. So what we have to do, we have to extract some juice from the potato, or you can take some rice water. When we boil the rice and throw away the water, you have to collect that water, add few drops of iodine solution in it. Iodine solution is originally brown in color. So if a starch is present, it turns blue-black. Or in any other solution where starch is not present, if you put iodine solution, it remains brown. So this is a very simple test we can even do in our school and in our homes as well. Test for glucose or reducing sugar test. So what we are doing in this test, you are taking some glucose solution. See the first test tube. You have taken some glucose solution and you have to add equal amount, the amount of the glucose solution you have taken, equal to that amount, you have to add Benedict solution. Benedict solution is a solution which contains copper sulfate in it, so it is blue in color. So when you will add Benedict solution and heat it in a water bath, the test tube must be kept in a container of water and it has to be heated in directly. That is called a water bath. So you have to heat it in a water bath. If glucose is present, the color of the Benedict solution turns brick red. Actually, brick red color precipitates form. And if in any other solution, if you are adding it, if glucose is not present, it remains, the Benedict solution remains blue. Okay. So this is the test for glucose. Add Benedict solution to a sample of glucose. Add few drops of Benedict solution. Heat the solution in a water bath. If glucose is present, the solution turns brick red or else it remains blue. The next test is the test for fats. So you have to take cooking oil and you have to add ethanol, alcohol in it, shake it well and add some cold water. Cold water means tap water, and shake it well. If fats are present, the solution turns cloudy. If fats are absent, the solution remains clear. Test for proteins, biuret test. So we have to take some egg white because egg white is rich in proteins, and we have to add some biuret solution. Biuret solution is blue in color and you have to shake it well. If proteins are present, the color you can see here on the screen turns purple. And if proteins are absent, the color remains blue. So this is the test for proteins. Test for vitamin C. This particular test for vitamin C is only for Cambridge students. Edexcel, IGCSE 921 students do not have this particular test. Otherwise, test for starch, proteins and fats is for both of them, Cambridge and Edexcel. So this particular test for vitamin C is only for Cambridge students. So what we are doing, we are taking little bit solution of vitamin C, which can be lemon juice or orange juice, and you have to add DCPIP solution in it. And you have to shake it well. DCPIP solution is blue in color. If vitamin C is present, the solution turns colorless. If vitamin C is absent, the solution remains blue. Now, there is another topic, calorimeter experiment. This experiment we are doing to calculate the energy value in a sample of food. In a sample of food means, for example, you have got a small piece of pasta or you have got a small piece of potato chips or a biscuit, and you have to find out how much energy is there in that food sample. So we have this setup. What is this setup? We can do it in the laboratory very easily. We have got a boiling tube, and in the boiling tube, you have to take 20 cm cube of water. Okay, so this water is actually 20 cm cube. So I'm writing here 20 cm cube. So if it comes in the exam, the values will be given to you. So the water is 20 cm cube, which is equivalent to 20 grams of water. 20 cm cube out of 100 cm cube, 20 gram out of 100 grams. So both of them are same. You have to put the thermometer inside it and you have to measure the initial temperature. Initial temperature is, let's say, T1. Okay. This is the mounting needle. This needle is a mounting needle and it is a metallic needle in which you will pierce the food and you will burn the food by keeping the Bunsen burner in such a way that the flame of the burning food should touch the bottom of the test tube or the boiling tube. And you have to completely burn the food and you have to keep on stirring the water with the help of the thermometer. Why? So that the heat may not be concentrated at one point, but the heat can be properly distributed in the whole water. So you have to continuously stir it. Okay. When the food will be completely burned, you have to measure the final rise in the temperature. Let's say that is T2. Before the experiment, you should measure the mass of the food sample. Okay, so we have top loading balance in the laboratory. So we will measure the mass of the sample of food. Whatever the mass of the sample of food in grams, you will measure beforehand. So what values we have? We have got the volume of water or the mass of water is equal, same. Initial temperature, final temperature, and the mass of the food you have already measured. Plus one more thing we have, that is specific heat of water. Okay, specific heat. So specific heat, let me tell you what do you mean by specific heat. It is a constant value and it is never going to change, and that is 4.2. So specific heat is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. Remember, suppose we have got in a beaker 1 gram of water. Suppose this water is 1 gram. Okay. And the temperature is, let's say, 20 degrees Celsius. So you have to heat the water till the temperature becomes 21 degrees Celsius. So the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius is actually the specific heat of water, and that is a constant value 4.2. So what values we have? See, we have got the volume or the mass of water. We have got the specific heat of water. We have already measured the mass of the sample of the food. Initial temperature we have recorded, final temperature we have recorded, and now we just have to put them in the formula to get the energy content, energy value of the food. So now let's see what is the formula, how we are going to put the values in the formula. So see what we have the mass of the food. For example, it's just an example, we have supposed that the mass of the food is 4.5 grams. We have assumed it is 4.5 gram, or let's say this question is given to you in the question paper. Mass of the food is 4.5 gram. This value is given to you. Initial temperature, let's say it is 23 degrees Celsius given to you. Final temperature, when the food is completely burned, the temperature which has the, how much temperature has been risen, 23 to 45 degrees Celsius. Okay. A specific heat is 4.2 and the mass of water is 20 grams. Okay. So the things which will be given to you must in the question paper are these three things. Whereas you should know these values: specific heat of water and the mass of the water, 20 gram. You should know this thing. So these three will be definitely given to you. Otherwise, you will not be able to do the calculation. Now let's move to the next part and see what we have. The formula is final temperature minus initial temperature multiplied by the mass of water multiplied by the specific heat of water divided by the mass of water. Okay. So if we put the values, final temperature 45, initial temperature 23. So 45 minus 23 multiplied by mass of water is 20 grams because it was 20 cm cube of water. So that is equivalent to 20 gram. Specific heat of water is 4.2, and the mass of the food which we have recorded, measured using a top loading balance is 0.5. So this is the value. When you will put it in the calculator, you will get this value. 4,400 joules per grams is the energy which is there in that sample of the food. Which sample? Which is 0.45 gram of pasta or whatever it is, a biscuit or a peanut. It can be anything. All right. But the energy the energy value which we have calculated, remember, this is not an accurate value. This is far too less than the original value, far too lesser than the original value of the food. The reason is there are so many sources of errors in this experiment. So let's see the sources of errors. Heat loss in the surrounding. Okay, so there is great loss of the heat in the surrounding here. Okay, there is a great loss of the heat in the surrounding. So you can see 100% of heat is not going in the water, but the heat is lost in the surrounding as well. Okay, this mounting needle is made up of metal, so metals are the good conductors. So this metallic needle also absorbs the heat. It might happen that you have not completely burnt away the food into ashes. Some food particles are left to be burned. It might happen that water is not exactly 20 cm cube. Some of the water is being evaporated because you are heating it. So the less amount of water, if it is a very slight decrease in the water, lesser the water, lesser will be the absorption of the heat. Okay, so it might happen water has evaporated, so the absorption of heat has decreased. It might happen that you have made a mistake in measuring the temperature. It might happen that you have made a mistake in measuring the mass of the food. So all these things are the sources of error, human errors, for which the energy value is not accurate. So what can we do? Now, what can we do? We can use a modern calorimeter. So you can see this is the modern calorimeter. It's a very close container. All right. The base of the container is heat proof. The base of the container is heat proof. So there is less, heat loss in the surrounding. So this is the base. This is the heat proof base. So there is minimum heat loss in the surrounding. Another thing, there is a chamber inside, and in this closed chamber, the food is burned, which ensures that the food is completely burned. The food is not exposed in the air for the heat loss or for the incomplete combustion. Then there is oxygen supply inside this chamber. So the oxygen supply means it will ensure that the food will be completely burned. Then you can see this is the automatic stirrer inside. You do not have to stir it. You do not have to take the trouble of stirring it with the thermometer. Automatically it will move up and down, and the stirring will take place. And this entire space, by the way, this entire container inside is filled up with water. Okay, this entire space inside, this space inside is filled up with, this space inside is filled up with water. So the food is burnt in a closed chamber here. There is no water in that chamber. There is air supply, and we are using electricity to burn the food. And then you can see the smoke, the exhaust gases which will come out. There is a coil tube, and with the help of this coil tube, the exhaust gases will go out. So what does it mean? It's a large surface area. The surface area of the coil tube has increased, so there is a maximum transfer of heat into the surrounding water. So the modern calorimeter we are using for the accurate measurement of the heat. All right. So these are the features of the modern calorimeter. Heat-proof base to minimize the heat loss in the surrounding. Food is burnt in a closed chamber. There is a passage of air inside the closed chamber, which ensures the complete combustion of the food. Automatic stirrer, you do not have to stir it. using a thermometer. There is an automatic stirrer and it will move up and down and it will distribute the heat evenly. Coil tube to let the exhaust gases out has a large surface area and there is a maximum heat release in the surrounding. So that's all for today. We have finished today the entire chapter of digestion, and there are uh, 3 videos so far for the whole chapter of digestion. So you can go through these videos for your examination revision. Goodbye, children. That's all for today.